So this morning I will tell you a bit more about the Sen2Agri system. I think this system you have heard about it several times during the week. You already had the opportunity to test it at the practical. And here we wanted to give you an overview of what it is and what it can do. So the talk will be split, will be shared by Pierre and me. I will start with the system, and then Pierre will come for the second part, and we'll go in more detail about the thematic exploitation of the products, how you can combine them and use them in different concrete applications. So the outline of the presentation is this one, very simple. And we will start with what is Sen2Agri. So the context is clearly that agriculture monitoring today is really a hot topic for different reasons. So there is a big international attention about the crop monitoring for the food insecurity first, but also for the market volatility. So you know that when there are some rumors or some predictions that the yields this year or the production this year will be lower than expected or higher than expected, it has a direct impact on the prices. And so there is a concern to avoid these fluctuations just due to, let's say, information which is coming or which is emitted by you don't know exactly who. There is also a clear link between the crop practices and the environmental assessment. And so this has been highlighted in different initiatives. So here, this is the G20 of the Ministry of Agriculture, and they put GeoGlam on their agenda, so the Agricultural Monitoring Initiative, so really the use of Earth observation for agriculture. And also at a different level, so for the SDGs, you can see the second one, Zero Hunger, which is clearly about food insecurity. And here for this one, all the columns are how remote sensing data can help to meet this requirement. So there is a big expectation from remote sensing data by the major institutions. And this is clear that we need to have better capabilities. And this is also clear that Earth observation can help. But the key question is, we have Sentinel-2. Sentinel-2 provides you images at 10-meter resolution every 5 days. But how can you exploit this big data flow to have your crop information at the field level, over countries, at country level, or it's sometimes even more, and in a way which is timeliness? So you know that this is a big challenge, and the timeliness is very a key question, a key objective specific to the agriculture. So in agriculture, when you have your information, if it comes 3 months after the season, even if your information is very accurate, it's meaningless. So you really need to be able to provide something at the right moment, which is a few days after the remote sensing data have been acquired. So the time between the remote sensing acquisition and the production of your information shall be as short as possible. Another key aspect in agriculture monitoring is certainly that this is a very sensitive information. So there is a willingness or need for the countries to make this processing, to derive these figures by themselves. This is their data. These data are super sensitive. And so you need to, when you think about Earth observation processing, you cannot imagine that you will pay a consortium to work on the cloud and that the country will give the data to the consortium to be processed on the cloud. This in agriculture, it does not work. Absolutely not. So the processing shall be controlled by the countries and the in-situ data shall belong to the country. This is very, very important. So they don't share data like this. And they want to control the figures that you will produce, because if someone outside of the country tells that the production of wheat this year will be such or such, for them it has no value. The ministry has to issue the figures. So there is really this requirement to include the final body in the processing, in the production of the information. And for sure there is the big volume of data. I will not come back to that. So this is a bit in this context that the Sen2Agri project has been initiated. So at the beginning, Sen2Agri is a project. This is not a toolbox. So this is a project that has been funded by ESA, and that was organized in 3 phases, which are there. So the first phases, the first 2 phases, in fact, took place before the first Sentinel data. So all the algorithm development and the first prototype products were done with the Spot Take 5 dataset. I don't know if you more or less know that, but basically Take 5 was at the end of its life, and so they proposed to modify the orbit to mimic what would be the 5-day cycle of Sentinel-2. And so with this dataset, we have developed some algorithm. And then when the first Sentinel-2 dataset was available, so in 16, we demonstrated the products with this Sentinel-2 dataset. After the project, we had 1 year or 1 year and a half more to work on the tool uptake. So to allow users using the system to make some tuning, because when the users use your toolbox, you always hear that something is missing, and that's normal. But so you try to improve. And in fact, this is still ongoing. I will come back at the end, but we have still many tools and many activities with the user community to work on the applications with Sen2Agri. So a specificity of Sen2Agri, and of many ESA projects, in fact, are the fact that this is a user-driven approach. So at the beginning, ESA has forced us, and forced is in this case, it is in a very positive way, but has forced us to work with a group of users which are here, so what we call the champion users. This group is made of international institutions, so you have FAO, you have the World Food Programme, IFAT. You have also some research institutes, international research institute, national research institutes, some ministries. And so this is a group with a different perspective, different, let's say, way of thinking what is agriculture monitoring. And this is this group that has defined what we call the user requirements. So they have told us what is needed by us in terms of remote sensing product. How they would use the remote sensing data, and so what we need to produce with the Sentinel data. So there was a first user consultation before the project in 2012 that was organized by ESA, and then in the project we started during the first month with a second user consultation that was at FAO, and then at the end of each year we organized the same consultation, so in Brussels, in FAO, where the results are presented and shall be approved by the champion users. So we have worked with the champion users. We have also worked with the different sites. I will show you at the next slides. And in terms of users, I would say that all the sites partners were as important as the champion users. So the champion users are persons that are used to work in agriculture monitoring and that guide you. But the national partners or local partners, these are the site where you will test your product, you will develop your algorithm, and these sites are sharing the data with us. They fill data, and they will validate the products for us. So we will give them the prototype, they will give us feedback, and we iterate. And this is the best feedback that you can expect when you develop the tool. You do not develop your tool within your research lab, and then when it's completed, you tell, okay, here is my tool, please use it. This is not like this. The users have been involved during the development of the tool. So from the user requirement, what appeared to be the top priority for the group of users were these 4 products. So an automatic delivery of the products along the season and from Sentinel-2 and Landsat 8. I insist, so Landsat 8, this was done before the Sentinel-2, and at the beginning we had only 1 Sentinel-2, so a repetitivity of 10 days. This is why we included Landsat 8 in the demonstration. Now the things have changed because we have the 2 Sentinel data, the 2 Sentinel sensors, sorry. And so the importance of Landsat 8 has decreased. I would not say that it is no more useful. So it depends really where you work, but if you are in an area where you have some cloud coverage, during 3 or 4 weeks, if you are unlucky, you have no Sentinel-2 acquisition because each 5 days there is a cloud. And by chance, you could have a Landsat 8 acquisition that is more or less cloud-free within this month. In this case, even if the Landsat 8 is at 30 meters, it's better to get it than having nothing during 1 month. If you are in an area where the cloud coverage is not an issue, I think that Landsat 8 shall be discarded because of the Sentinel-2A and B. So the 4 products are this one. So the first one are monthly cloud-free surface reflectance composites at 10 or 20 meters, depending on the bands. Sorry. And then we have the Cropland mask and the crop type map. We have already talked about it. So the Cropland map is a binary map at 10-meter resolution, and which will come every month from the mid-season. And the crop type map is also at 10 meters. Then you will go already to the crop type, and the product is delivered twice along the season, at the middle and at the end. And finally, we have biophysical vegetation indicators that come each time there is a new acquisition. So the algorithms have been developed, and the prototype products have been generated over a variety of sites. You can see here all the sites, so what we call the benchmarking sites. Most of them were GCAM sites, but not all of them. And so over this site, we have been working with the local partners that have shared the in-situ data, and we have shared our research results with them. So the algorithms were selected by a benchmarking. So for each of the 4 products, we have tested in each site between 3 and 5 different algorithms. And we have selected the algorithm that performed best over the 12 sites. So we did not select the algorithm that gives the maximum accuracy over one site. We took the algorithm that had the best performance for all the sites, because we wanted the Sen2Agri shall be operational in a variety of agriculture practices. So this is something that needs to be known. So these were for the benchmarking, the kind of prototype products we had. So you can see that over the test sites, you have some, here you have the Burkina Faso, yeah. You have some European countries like France, Belgium, Ukraine with the big fields, Pakistan, very small fields. So different types of landscape. And so the algorithms that have been selected are the ones that, in average, perform the best. And then when we had this algorithm selected, we had the first Sentinel-2 data, and we went in the phase of the demonstration of the products. So the demonstration, there were 3 countries, so Ukraine, Mali, and South Africa, that we had to process full scale, and 8 local demonstrations, 4 in Europe, 3 in Africa, and 1 in Asia. The demonstration consisted in generating the product by ourselves, giving the product to the users, receiving the feedback, and at the same time organizing capacity building activities on the products and on the tools. And so you can see here some pictures of this. And for the 3 national case, we did some workshop within the countries where all the stakeholders of the country were invited to present them some products that could be used in their own applications. So what is the Sen2Agri system? So this is here. This is an open source system which has been demonstrated. It can be run in real time or offline. So you can really monitor the season, but you can also use it to process after the season or reprocess after the season in your area. And it can be run locally on a server or on the cloud. The Sen2Agri system includes, so it is reading or downloading level 1 products. It is including a module for the atmospheric correction and for processors to generate the 4 products I have presented at the beginning. So it is implemented already on some clouds. So it has been tested on the Amazon cloud, on the IPT, which is the precursor of Create.is. It is currently implemented at EODC, which is a private cloud. So if you can pay EODC to run Sen2Agri for you. Here, this is an example of the World Food Programme. They are using Sen2Agri, and I will show you. I will talk about that a bit later. So I told you that the project is over, but now we are really in a phase of uptake, or let's say support to the community. So these are the statistics of the download. Who can be interested in the system? So for who it is. So in fact, any user that is interested in agriculture monitoring could be interested by the system at different levels for sure, but they could be interested. So these are national services for agriculture monitoring. This can be national statistical offices, also international agencies, researchers, private companies. There is no restriction. The system is fully open source, so there is no restriction on the license neither. Now so the system is there. We put there is a website where you can download it, and we put some resources for the users. We try to be as active as we can. So there is a forum with different topics, the different processors, the installation, the use of the products. This is rather active, I would say. We try to be there as quickly as we can. Sometimes there are periods where it's a bit more difficult, but we try to manage it. There is a frequently asked questions on the website, technical documentation, and also every 2 months, more or less, we organize webinars where we inform about what is new, and where we also receive some experience which are shared by the users who has used it, if they encounter problems or so on, or if it was successful also. It happens. Okay. So this is for the general presentation. Then how it works. So Sen2Agri can be operated in 2 different modes. So the first mode is what we call the automated mode. So you have seen during the practical that you can operate the Sen2Agri through a graphical user interface. And using that, you can do it really automatically during the season. So before the season, you parameterize the system with your site, the period you want to monitor. And then you select the processor you are interested in. If you don't need the composite, you can just discard it, for instance. And you launch the production, and the production will be done automatically. So if you ask for a crop mask every month, there will be a crop mask that will be automatically generated every month. You can just go and download when it is ready. So the resources are managed by a tool which we call Orchestrator. So this is this tool that will manage the resources, that will optimally allocate the resources between the different jobs that are ongoing. And then you have the manual mode. This is what we have done during the practicals. So you can add or request some jobs. You want a crop type, you want a crop mask, you want a time series of LAI over a certain period. You can just do it on request also. And this manual mode can be done through the user interface, like we did. For those who are very comfortable with Linux, you can also work with command line. And the LAI and composite processors can also be invoked by Snap. So you can, if you are familiar with Snap, you can work with the composite LAI through the Snap interface. So before the season, you need to initialize your system. So you need to define the area of interest. This is one shapefile. The monitoring period. Decide if you want to work with Sentinel-2 only or also with Landsat 8. If you are working at national scale, we recommend you adding a stratification. So not to work at the full scale. And then you also need to anticipate a little bit that for the crop type and possibly for the crop mask, you will need field data. And so this is time to design a little bit the campaign or the data collection, let's say. And then when you launch the system, what is automatically done and systematically, this is the download or reading of the L1 data, and it goes to the level 2. This is done in real time along the season. So this is not, if you ask a crop mask for April and you launch your system in February, the system will not wait April to pre-process the data. Everything is done as soon as the system is launched. If you have asked for the LAI, each time your data will be pre-processed, your LAI will be available, will be generated and also available on the product tab. So the LAI time series is really building along the season. So for the crop mask, so as this is what I told just before. So the pre-processing is being done along the season, but you need to wait more or less the middle of the season, let's say, to have 1 or 2 months of data to initialize the system. And so you are also asked to, if you can, for the crop mask, to upload your in situ data. And then with this, you will have your first crop mask that will be produced. And then for the crop mask, as soon as the data, the Sentinel-2 data are processed and acquired, each month you will have an updated cropland that will be generated until the end of the season. If you have the chance to have to do 2 field campaigns during the year, which is optimum, but sometimes or often not realistic, you will upload your second field data set, and then you will get the crop mask at the end of the season that will use this second field data. If you do not have a second data set of field campaign, probably that the first one will come a bit later, and so you will have your first crop mask here, and then for the next one, it will work with the same field data set, but it will just benefit from the additional Sentinel-2 data that are representative of the current period. And for the crop type, this is the same, except that you will have only 2 crop types, one at the middle of the season and one at the end of the season. And for this, you absolutely need the field data. For the crop mask, there is an option to do without, but for the crop type, you absolutely need it. And so for the crop type, we decided to propose only 2 products. Depending on the season, there can be more, but probably that really a monthly update of the crop type will not be as accurate as the cropland mask. Okay. So just to summarize, if you go for national monitoring, before the season, you have to set up your hardware, design your field campaign, and prepare the data for the system initialization. Then at the beginning of this season, you initialize your system, you launch it. There is an automatic pre-processing, automatic production of the LAI along the season. For the composite, it's not every day, but it's every month or every 2 weeks, but it starts at the beginning of the season. Then you will have your field data that shall arrive. And from the moment you have this field data, you will have the crop mask and the cropland that can come, possibly with a second field data set that come at the end of the season. This is how it works. I will show you. Yeah. If you can take the mic.
Is it possible to transfer models from one season to the next year, so we don't have to do a field campaign again? So can we use our cropland mask from 2017 for 2018 or 2019?
Well, this is a question that is not specific to Sen2Agri. I think this is a key question that all the community is asking for the moment. This is really not clear that field data from 1 year can be used for the next year. Why? For the non-cropland area, I think yes, because these are rather, this forest, this water, building, you do not expect many changes on this area. So once you have a good and representative data set for the non-cropland area, what we recommend is that you can use it the next year, just check that there is no big change, but you don't have to recollect it again. For the crop type, first there is you should, it's not reusing the same data set because there are rotation and so on. So Then there is the possibility to extract the spectral signature, the typical spectral signature of a crop type, and you apply this signature to the year after. With optical data sets, I have never heard that it works. Why? but I think this is the next step. For the moment, this is not really. Why? Because the optical data sets are so sensitive to the atmospheric conditions, to any shift in the phenology. The shift can be, let's say, readjusted, but probably not so good in real time. But the atmospheric condition, the atmosphere 1 year and the other years at the same date can be completely different. And so your spectral signatures, I do not expect they will be so stable. But I hope that we will find a way to handle that quickly, because this is really the critical thing, is to get the field data. So I will show you some example. I think that the experiment over Ukraine, you have already seen it a lot of times since the beginning of the week. So I will be very quick and I will go to new ones. So these were, in Ukraine, they were able to do the 2 field campaigns. I think this is the only country where we were able to do that, where they were able to do that, because these are the local partners who did it. And so they did it by cars along the road. I guess that, Pierre, you have explained you this yesterday during the lesson. So this is the first product, so the LAI along the season that has been generated. This is an example over some fields, only with Sentinel 2A. This is why the time series is sparse. But still, even with few data, you get a good idea of how the vegetation is growing. This is the first Cropland map that you have discussed the accuracy yesterday. There were also the crop type map. So we did the map for the 5 main crop types with an overall accuracy of 81%. And from this, we derived some crop distribution at the oblast level. So during the meeting we had in Ukraine with the different stakeholders, one of them was the Ministry of Agriculture, and they were rather impressed. And so they proposed us to compare our results with their statistics at the cropland level. So the crop type information was not shared. But the cropland level, we compare the official statistic for 2015 with the cropland area for 2016 that we derived from Sen2Agri, and this comparison was by oblast. I must say that the statistics were for the sowing areas, not the harvested areas. And you can see that there are very few districts where the product is completely off, and the relationship was also quite good. So for the Ministry of Agriculture, this comparison was really convincing, and so since this they have really invested in finding national partners that could support them. So this is really not us to support them, but there are national partners that can do this kind of job. Then the combination of the different products. So when you have the crop type at the LAI, you can start to do a crop-specific monitoring, so you can see the evolution of the wheat or of the different crops. The second example is in Mali. There we have been working with ICRISAT and IER, Institut d'Économie Rurale in Mali. I think we have some partners here. We relied on the CPS, so the cell from the planification and statistics, they are organizing national surveys for their activities, and we rely on this survey to get the data for the demonstration. And for the non-cropland, there was an on-screen interpretation around 2,000 samples. So you can here see some pictures. So from the CPS, we have received 30,000 GPS points distributed all over Mali. And I insist on the fact that you should quality check the data that you receive. So here, from these 30,000 points, first there were points, so they needed to be transformed into polygons, because Sen2Agri needs polygon, not points. And so this work was done by the team of our partner in Mali. and was also clean, because you can see that some GPS points are completely outside of the country. So I mean, these were removed, and you had to trust that the other ones were correct. This was the first, the quality check was really important. And so at the end, we only ended with 10,000 manually parcels. And we relied this parcel only for the cropland, non-cropland information, not for the crop type. Why? Because in the region we had more than 40 crop types with a single cropping system, but more than 203 association mixed crops. And so at the end it was so a mess with a reliability that we could really question, that we decided not to go to the crop type. We tried, but the results were absolutely not reliable. So these were the different composites along the season. The last one from November. So even with one Sentinel, so you can see still some artifacts here. But this was not bad. So this is the kind of crop mask we had with an accuracy which is good. So here you can see the croplands, the different patterns, and in the cropland mask it appears like this. Another example here. So I told you that we were not able to go to the crop type, but then the year after, they decided to invest a bit more, and they've asked us to go another year with them for the crop type, and we focused only on the cotton belt region, which is 12% of the territory, but which is the major agricultural production of the country. It's more than 50% of the production comes from this region. And then we worked a lot on the capacity building for the field campaign, because what was missing was the data set. So we followed the GCAM protocol, so windshield survey using motorbikes. They visited 28 villages, and they collected the information about crop type using an application which is called GeoDK. Maybe you know it. So at the end, we had a lot of points, and most of them were useful. A lot of work at the office to go to the sample also. And we have been able, just a year after, to go to the crop type with an accuracy which is not bad at all. So in this region, well, this is not the same accuracy that you get in Ukraine, but for Mali, this was the first extensive mapping, we would say. Every whole square kilometer of the country is mapped, and getting this accuracy for first time was rather promising, and so they are continuing working on that each year. In South Africa, I just wanted to show this example, not for the product, but to show another way to collect the in-situ data. So here they collect in-situ data. They're very well organized. Each year, there is a very light aircraft that is flying over a predefined transect, and there is someone in the aircraft just collecting the crop type. And they fly once along the season, but they get an incredible amount of polygons, which are quite like this. So they are working with this system since more than 10 years, and each year it's becoming better and better. An example of LAI. And so at the end of the season, you get this kind of profile. So you can see that even in South Africa, you can have some long gaps without any information. Well, it was with only one Sentinel-2. And the crop type, which was quite good in the country. So this was, the examples I've shown were examples that we have done by ourselves. During the demonstration, and now I will show you some examples that users have done by themselves, because it's even more convincing when we promote products that we have not done. And so the World Food Programme has tested the Sen2Agri system. So they are working with Sentinel-2 data. They go on the field to collect crop type information with the GeoDK application, with an online platform, and then they are working with the EODC cloud. So they have started working on Sen2Agri in South Sudan, which is really not an easy case to start, but this is their area of interest for sure. These are not easy countries. And so when they send the people on the field, they put different level of requirements. So if you can, you have to go and to make the full perimeters with your GPS. Sometimes it is good that the people do it on the field, because if you are in the office and that you have to guess what is the field corresponding, what is the polygon corresponding to one point, it can be very complicated. So this is really the preferred option if you have time. Then if you have very large fields, you don't have time to go and to make the full perimeter, and so you take the track and you take a note, the field is on the left or on the right, orienting you in the north or in the south. And then at the office, you have to just draw the polygon. When you have very huge fields, you can take points, or you can just draw the corner to guide the exercise at the office of the making the polygon. When people go to the field, they go for 2-3 weeks, and so they upload their data on an online platform every day. And each day, at the World Food Programme, there is something that will make the quality check. If something is not good, they can inform directly the enumerator, and so the enumerator can correct. And in this way, at the end, you are sure that more or less you have something useful at the end of your field campaign. So this was for the field campaign. Now coming to the typology. So the agricultural practices in South Sudan is really not easy. So if you want to cover everything, you can see that, for instance, for the sorghum, you have the early and late sorghum, and you have the sorghum only or sorghum with mixed classes. And so they have tested different level of aggregations. Here, all the mixed were grouped in one for the early and late sorghum. Here, they mixed late sorghum pure and late sorghum mixed in one classes. And here, in the last case, they all mixed all the sorghum in one case. So, what is a mixed crop? So, when you go to South Sudan, the abundance of the crops within the mixture can vary between 30 to 70, and this is optimistic. So here, when you go to the field, you will say, okay, this is groundnut, and this is maize. I would say that the maize, you have no chance to see it on the impact of maize on your Sentinel-2 pixel. It will not be there. So you shall tell your enumerator that if it's like this, he shall record single crop groundnut and maybe put a commenter like presence of maize. In this case, this is much better balanced between the beans and the sorghum. And so all this problem of mixed crop is very difficult for the enumerator to decide, and so it adds also uncertainties in the classification. They tested, and so they split the country in two strata. So the region where you have early sorghum mixed and late sorghum mixed, this kind of detail was correctly classified in the stratum 1. But in the stratum 2, the results were absolutely not reliable. And so for this stratum, they had to aggregate more until a single class of sorghum, and they get this kind of result. But still, this legend is useful for them. And so with this kind of results, they decided to adopt Sen2Agri in their operational use. So now, in the World Food Programme, when I say adopting, it doesn't mean that they have just stopped the traditional way of working, but they are running Sen2Agri in parallel. And I think the parallel will last 5-10 days to build the history, to acquire the knowledge, and so on. But with Sen2Agri, in parallel of their current practice, they have the 10 meters. While with the current practice, this is modest, 250 meters. So, and this is this was done by them, not by us. We supported them for sure, but all the classifications were done by them. Another example in Australia, so by the CSIRO, where they have used Sen2Agri to map their rain-fed farming system. So you can see that this was only with Sentinel-2A also, and the amount of cloud-free acquisition is rather low, but still the results were convincing for them to map their rain-fed farming systems. So they were rather happy, and they are continuing using it. They are trying to apply it on the grassland also. So maybe, because grassland is a key ecosystem in Australia. So Sen2Agri has been also used by the Dalberg Data Insight, which is a private company. They, in fact, use Sen2Agri to produce the crop map and the crop type, and the crop type will feed a crop yield model to that will display some information online. So this is a portal that has been requested by FAO Uganda, where this portal is not only agriculture, but so you have the different communes with the population, the area, the crop area that comes from Sen2Agri, and here the production that comes from the yield model with the crop type information. Sen2Agri is also used by the CIMMYT. So here it has been, I will show two examples. The first one is in Bangladesh. I wanted to show this one because the size of the fields is rather small, but the accuracy were not bad at all for the crop type mapping. These are sites where the control of the field data collection is quite good, so the data were very accurate and reliable to make the classification. And another site in Mexico where they are also working on the crop type. In China, it has been also used to test over unirrigated parameters with promising results, but this was more at the research level, so it's not operational for the moment. And then, I've told at the beginning about the GeoGlam as the, let's say, big initiative. So in the 2019 report of what were the activity of the past year, so Sen2Agri has been put as an unofficial delivery that could really help them to achieve the objective. And so you can see here, so open source system. For us, this was, it means really that we are at a good level of operationality and that it is ready to be taken by the users to be used in their own application. And the last list of, let's say, updates is this one. So these are experiments that have been done by us or by partners and that have allowed going to new applications. So Sen2Agri has been used to define what could be the Copernicus Agricultural Service. It has also been used to in a feasibility study over Czech Republic with the paying agency. And the results were convincing enough to go to the Sen for CAP, so how to use Sentinels in the context of the CAP reform. Sen2Agri is supported by the food security tech that you will hear about tomorrow morning. And Sen2Agri, the results over Ukraine and Mali were convincing enough to think that this kind of product could be useful to support the agricultural statistics. And so there will be a new project, there is a new project starting on this topic. So to summarize, this is Sen2Agri, so open source. It is able to produce high spatial resolution product for agricultural monitoring at local scales, from local to national scales. It can work automatically with Sentinel-2 and potentially Landsat 8 time series if this is useful. It is a Linux system, but through the graphical user interface, you can interact quite easily with the system. Free and open source. This is a classical GPL license. And, well, the data privacy, so for the field data, there is a possibility to process everything locally. So if this is a security issue to go to the cloud to upload the data, there is no need to go to the cloud to run Sen2Agri. And this slide, I think that Pierre showed you yesterday. So when you look at the different milestones to get an operational system, Sen2Agri is really almost fully operational. And so it's only waiting for you. In the afternoon, there will be a practical session on this to show you how to, really from the scratch, how to install it. And there will be also very detailed information about the specs, what you would need to run Sen2Agri. And we will go the step-by-step exercise with you if you are interested. And later on, don't hesitate to go on the website or to come with me if you have any question. I will be happy to answer you. And no, this is good because Pierre is there and he can do the second part of the talk. I don't know if there are questions. Yeah. Just wait. I need to give you the mic.
Thanks. You were telling us that you can derive LAI maps. Can you indicate which crop are you having to estimate, or which model do you use to estimate this LAI? Or it's can you define the crop you're using so you can have a model to describe it well?
Do you mean that the retrieval of the LAI should be crop specific? This is what you have in mind?
I don't know. Yeah, I was thinking about that.
Well, it's a good idea. And actually, Grégory Duvillier did his PhD thesis on this. And we just use Marie's Weiss algorithm to see if being crop specific, we will gain in accuracy. And at the end, it's so little that we consider that the retrieval of the LAI can be very generic and can be all crop combined. And therefore, today, I don't think anybody is doing a crop-specific retrieval algorithm to retrieve more precisely, because we are already good enough. And as you have seen, the in situ measurement is probably worse than what we can measure by satellite. And therefore, at the end, you can improve, but you don't know what you improve because you are lacking the benchmark. Therefore, to reply very precisely, the Sen2Agri system is delivering LAI for all the crops at the same time.
Thank you for the presentation, Sophie. I'm wondering, you mentioned the crop type mapping also has an option to differentiate it between irrigated and non-irrigated crops. Has this been investigated by somebody already? Are there some results?
Well, it has been. It really depends on, in fact, on the interest of the area. So it has been tested in Madagascar. Madagascar was one of the local sites we had in the demonstration, and in Madagascar, what we tested is the possibility to have different legends at the middle of the season and at the end of the season. Because clearly, at the middle of the season, you can come with all the crop types. There are crop types which are only bare soil, and so for them, at the middle of the season, they wanted to know winter, summer, and irrigated and non-irrigated. And so this was, but in terms of field data collection, they do not collect irrigated. They collect the crop type and irrigation, non-irrigation. And you use this information to train your model, to build your model. But at the end, you merge the classes to have only the split between, so winter crops, summer crops, and for each winter irrigated, winter non-irrigated, and the same for the summer. And the accuracy was quite good, more than 75–80%. In Madagascar, you also have to deal with the small field, so there were different effects at the same time. But yes.
I'm afraid that if we take all the questions, I will be again short in my presentation.
Mine was very short. Sophie, very short questions. One, you show us the comparison of this sowing area in Ukraine and Mali. Have you tried to see what happens to harvested area? Were they comparable? That's one. Quickly, you mentioned Sen2Agri is not a tool but a project, and you also mentioned it's ending, or it's going to end. So what about the maintenance, the improvement? What do you expect in the future?
Thank you for your question.
This is as we work. Thank you, Sophie. To reply to your question about the maintenance, luckily enough, after Sen2Agri, DG Agri requests ESA to have a project. Then we have been working hard on Sen4Cap. Sen4Cap is merging Sentinel-1, Sentinel-2. And very recently, we have kicked off the project called Sen4Stat. And therefore, we are good developing and maintaining Sen2Agri for 3 more years, probably more, probably 4. And therefore, we are good for that. Now we discuss also with ESA if there would be a chance to have Sen2Agri as a tool in SNAP or as a tool in a virtual lab that ESA want to support. Therefore, there are different strategies because the key is to maintain for sure. But we are on the safe side for more than 3 years. I propose to to go along this example because probably it will also. You had another question, I forgot. Yeah, I will come to that. Okay, I will have 7 sections. Maybe in some I will be quicker than others because this is probably already well known by all of you. You know that today, what is operational is this kind. You have a global early warning system which are running regionally or globally. You have very advanced crop growth and crop forecast, yield forecast by the Mars project, GRC, and this is probably the most advanced solution existing now. And you have all this precision agriculture which is running for various cases, but in very mechanized agriculture. You know that basically today, when we look for food security, this is the kind of approach that is being used. This is anomaly detection, similarity analysis. I will not go into this detail. I mean, Kenneth, for instance, here is running that kind of system, I believe, and many others are very familiar with that. This is when it comes to national level. This is 250-meter national early warning system. This is very nice because it is targeting a given country and reporting as a bulletin. But this is again 250-meter resolution from Moody's. When we want to recap what is the currently operational use of Earth observation for agriculture, you get that kind of scheme. This is a bit complex, but if you will read it carefully, you will see that probably this covers all the aspects of the current agriculture use, Earth observation use in agriculture. What we want to do, and what is Sen2Agri and other players do, is actually to explode it. We don't want that anymore. We want a better one than that. Because we got all this fleet of satellite, we have all this computing power, we have all this network, CEOs, GCAM, and others, with ACMIP and so on, which allow to work together. We have all this in situ data that you heard yesterday and tomorrow again, which are coming. And therefore, what has been the main target of Sen2Agri is to put all these components together to make our life easier and to work on actual advanced product. We want that the basic products are done, and therefore let's do the real stuff. The basic products are there, and then we need to use that. And the use is this. It can be very complex: agriculture practice monitoring, early yield forecasting, crop production, and so on. Let's go through those. This is the target. Here is what has been done in Mali, LAI retrieval. And of course, you can retrieve LAI, not at 250-meter resolution where you get the fallow and everything, but only for the planted area. Of course, there is some noise, as you can see, but we are in Mali. This is not easy. And therefore, you can monitor no longer the landscape and the greenness of the landscape, but all the field in Mali in particular. This was done with Suleiman, Solo, as he introduced himself, and Marie-Julie. That kind of crop-specific approach changed completely the life. It changed completely the way we can use remote sensing. Because now we are crop-specific with each observation. The LAI is retrieved for all, but I know that when I look at this pixel, I am looking not at the LAI of a crop, but as I have a crop map, I can mask the crop mask, and I use the wheat mask. Here I will use the maize mask. And then I look at the LAI development, the MSAVI in this case, or the NDVI. And then I can detect the emergence date of the maize. And this is what has been done here in South Africa. This is the detection of the emergence of the corn for all the field of maize in the Free State. And this has been actually done for the insurance company because they want to make sure that they insure a crop which has been planted and planted at the right time. And this has been completed, and it will be part of the training this afternoon. This Aspen showed that, and we have two colleagues from India, and they do much better than that. They say that they provide the yield estimate in rice for the whole of India using Sentinel-1. Where are you? Ah, here. Acreage, okay, not the yield. Here, what they do, this is CESBio work, this is detecting the development stage. This is quite interesting to detect the development stage of a rice, because of course you will be able to model in a better way the yield. You have seen that many times, but I wanted just to say that, okay, that's easy to have the cropland, the crop type, it's feasible. Then you have the wheat mask. This is only the wheat, and you can assess all the wheat field at 10-meter resolution for Ukraine or for any country that you have processing. And then you can retrieve the area indicator. This is not the area estimate, an area indicator at mid-season and at end of season for the main crop in this case. Per oblast, we will do that this afternoon. I mean, we were very surprised when we went there in 2016. The ministry has already its early area estimate of cultivated area. And as we were with the deputy minister in the meeting, they say, can you come tomorrow? I will show you our data. And then we did the correlation, 98 R square. We were very surprised to be so accurate. And then we say, okay, we have two other ones that are off. You know which one are they? This is the one where they could not go as Minister of Agriculture from Ukraine because this is occupied by Russian. And therefore, the satellite was able to say something while their figures was actually different. Because they could estimate from the previous year, but not from the current survey. I don't know if Sophie has shown that. Yeah, okay, then I skip this one. And then I will go directly to the third example. This is what we are doing with a Belgian farmer. We call it Belcam, as a Belgium Collaborative Agriculture Monitoring. And this summer, we launched it for all the farmers in Belgium, where actually this is very classical. Very classical. We display the LAI for their own field. Here, in this case, this is all the wheat field. And is this the wheat? Yeah, it's probably the wheat. The wheat field and the blue parcel. Actually, I can look at the meteorological condition of the past and the forecast using the closest station. And therefore, I have the LAI. I can look at the meteorological condition from the past. But what is most interesting for the farmer is this is my parcel with a dot which are measured from LAI Sentinel-2 from Sen2Agri. And the dotted one is the average of all the wheat field. Is it this wheat? All the winter wheat field in 3 kilometers around these parcels. And this allows the farmer to see if its management is better than the average management in the neighboring field, sharing the same climate condition, because 3 kilometers you have the same climate, and probably sharing the same kind of soil. And the farmers are very keen to see, am I better or lower than the average of my region? They can also look at the intra-field variability, of course, for management unit zoning, as Mirko explained this morning. Of course, this platform allows the farmer to put also many things that they are doing on their field, but we use also the F-cover that we retrieve from Sentinel-2Agri to model the aquacrop. Aquacrop is a yield model developed by FAO, which is a very simple one, but good enough for us. And actually, we estimate for this parcel the value of the yield we could expect in this area for this parcel. And this is a distribution of the neighboring farmer for the same crop. And therefore, they are very interested to see, okay, I reach the same level than the average. Or I am better than anybody else. I am topping the best yield in my region. We are not claiming that we got the exact yield, but in relative terms, this is rather good. And the R square, I mean, the error for the winter wheat, for instance, is something like 0.0 tonne per hectare, which is rather reasonable, but still not good enough. We would like to improve that. But when you have that, okay, the farmer is happy or not showing its performance compared to its neighbor. But then we want to see why it was like this. And then we use what Mirko introduced this morning, the NNI, the Nitrogen Nutrition Index. This is to look if the farmer get this very high yield because he put too much fertilizer. And he invests actually much more than any neighbors, and he spill over the environment. And maybe he get a very high yield, but actually he lost his money. And therefore the NNI, this is the story of the NNI of this parcel. In Belgium, you have to put the second fertilization mid-April. The NNI was much below 1, which is the best, I mean, the optimum from a physiological point of view. You want to be at 1. Mid-April, the assimilation by the plant is not done yet. Therefore, you have an NNI very low because you spray your fertilizer at mid-April. Now it's absorbed, and by mid-May, it's getting higher because your fertilizer has been absorbed by the plant. The plant develops himself, and mid-May, you fertilize the third time. And then it is assimilated, and you see that later on, you reach a 1, which is the optimum from a physiological point of view. And then as the crop develops further, you dilute the nitrogen in the biomass, and then your NNI is decreasing. Therefore, this is a very good farmer. He managed the optimum of physiology. It's maybe not the optimum from an economical point of view. It could have maybe probably lower and keep, maybe he would reduce a little bit his yield, but improve his rentability. And for sure, he did not exceed in over-fertilization. What we want to show is this guy has been better than anybody else because the average is the dotted line, and in average, in our region, the farmer over-fertilize. They lose money because they put too much fertilizer and they destroy the environment and the water quality. Wait, yeah?
Is it possible to have NNI value lower than 1 in April?
Yeah?
The farmer
But in April, that's normal. You are at the end of the winter. The start of the growth is already there. And then mid-April, you fertilize. But mid-April, you measure at the same time. It takes 2 or 3 weeks to get the plant to absorb your fertilizer. Therefore, mid-April, you are still very low. This is our understanding. You have another one?
No. I mean, I was wondering if it's possible to have any good condition of plants, so value higher than 1 or around 1.
No, you don't want to be above 1. We would like, this tool is really to help the farmer to optimize from probably agronomical or physiological point of view, never above 1, and probably help them to go below, because having a yield which is a little bit reduced but much less fertilizer will be a better business for them, a better return in investment. And of course, sustainability will be, and this is the purpose. And we don't want to put any pressure on the farmer. We want just to tell what is observed. And the farmer can decide to over-fertilize or not. It's not our, but we want to let them know that they over-fertilize. And today, this is running online for all the farmers for free, and they can look at it, and they register. If you want, you can have a look. This is belcam.info. Sophie mentioned that we are also working on a Sen4 and I don't know how much you mentioned about it, not too much. This was a request from the fellow gang, the commissioner. And luckily in Europe, you know that the orbits are converging, and therefore we get more than 5-day revisit cycle. You are 3 days basically with Sentinel-2, and with Sentinel-1 close also to 2 days. And therefore you got plenty of data. And then you have that kind of animation that you know, I'm sure you have done that many times. You have 3 parcels, and this is, in this case, the NDVI, and you can see this is cloud, but also some information. And then you have the harvest, and you can detect the harvest, and then it will continue. And then you have the cover crop or the winter crop, which will be coming. After the harvest, you want to classify your crop type. You can check if they are compliant with the declaration of the farmer. And then you can continue the cycle and see if the farmer are compliant for the management of the winter cover crop. They have to plant before a given date and not to harvest before another date. Therefore, this is the tool that the Commission wants to use for the Common Agriculture Policy, for the reform after 2020. And to do that, actually, we were asked to see if we can develop markers. The GRC asked us to develop markers because this was the view they want to look at. And therefore, the markers are concerning these 4 applications, and we will look into this detail. Actually, to develop the marker, we use the full Sentinel-1, the full Sentinel-2, and for each polygon, because in Europe, the farmer has to declare and therefore they provide you the parcel boundaries, and therefore for each parcel, every 10 days, you have 22 matrix coming from Sentinel-2 and 16 matrix coming from Sentinel-1 every week. At the end, you have 130 matrix per month per parcel. 130 matrix per month per parcel, and this should allow you to tell something about the parcels. Kind of matrix are this. These are matrix which are turned into marker, and this is the 10 marker which are used to assess the agriculture practices from the farmer. This is nothing very fancy. These are things that you probably use. One of these are the mowing event detection. You know that farmer today, they can declare a pasture, but they have to show that this pasture is managed at least once. It cannot be any grassland that they claim that this is a pasture belonging to their farm. This is a pasture which need to be at least mowed once. And therefore, you use the Sentinel-2 time series, and you can monitor how many times the farmer will mow the grassland. And this is one source of information coming from NDVI, LAI, and FFPA. And you will see the mowing inducing a decrease. And this is the actual mowing are in blue, and the decrease of NDVI is in green. And therefore, that's rather trivial to see that the biomass has been removed. You can use also Sentinel-1 because it can be very cloudy. Therefore, you cannot see the mowing, and you need to mow only once. Therefore, you don't want to miss it. And then the coherence on VV, coherence of VH that Ramon introduced to you will actually increase suddenly if you mow. Because the coherence, if you have biomass, is rather low. And when you cut, there is no more biomass. The coherence for the two next orbit pass will be very increasing. And then, of course, the biomass will regrowth and it will go down again. And therefore, you can detect by the convergence of information from Sentinel-1 and Sentinel-2, you detect a number of mowing events in the different grassland. Right now, we are validating that for 6 countries with 500, hopefully 500 parcels. But up to now, we only validate with some tens of parcels in different countries. But it's not large-scale validation yet. Our colleague from GISAT, I know someone is working with GISAT, isn't it? We heard that yesterday. Our colleague from GISAT has developed also a role-based approach to interpret this kind of time series. This is the coherence in VV, in dark black. In red, you have the backscatter ratio VV-VH, and DVI in green. And you have that, you see many times, every 3 days or a little bit more or less. And DVI much less because you have cloud. And this time series allow you to interpret the agriculture practices. And therefore, typically here, this is the harvest time. Harvest means the coherence will increase, and DVI is at the minimum. And therefore, that's easy to confirm that the backscattering coefficient ratio is increasing, the coherence is increasing, the NDVI is at the minimum, you are sure that you have harvested the crop. We use either Planetlab or Sentinel-2 here to see that this is correct. And then you can see if the cash crop is planted at the right time and harvested, not harvested before the right time. And therefore, this is the same kind of approach. You see that your NDVI increase again, the coherence is low, and therefore the maintenance of the vegetation is properly done. This is done here in the case of Republic of Czech Republic, according to their own regulation. What you have to know is the target of the Common Agriculture Policy reform is to stop the control of the farmer and to change this into a monitoring and stopping controlling the farmer, helping the farmer to do the right job. This is really the idea, and therefore this is why we are working on that. We want to give the information to the farmer that he needs to mow his grassland, because we have not seen the grassland mow yet, and if he wants to stay eligible, he has to mow within the 3 weeks, for instance. And the idea of the cap is to send a SMS to the farmer to tell him, if you want to stay eligible, please mow your field. And therefore, the idea is really to help the farmer to have sustainable practices. Our idea, and the challenge for you as for us, is, okay, when you have 130 metrics for each parcels, could we say something about the sustainability of the agriculture practice? This is probably the challenge for the European agriculture. I mean, we know that it's not so much sustainable today. We have to improve the agriculture. Can we make use of these 130 metrics to help the farmer to be more sustainable in their agricultural practices? This is pushing too far to ask the CAP to do that, but as scientists and researchers, I think we have to do that. We have to help the farmer with all this to help them to be more sustainable. I think this is not fair to use this only for regulation and not to support the farmer. Today, you have 6 + 1 + 1 virtual machine running in real time for 2019 for full countries. This is running for Italy, Romania, they are there, and we have had France and Luxembourg on their request. And this is running now, because this is a full-scale demonstration, while it has been run in offline, in non-real time, in 2018, already for all these countries. Of course, this is tens of millions of parcels which are running and implementing all the rules to detect the agricultural practices. Sen4CAP will be another package available open source as soon as this is qualified by ESA. Now I would like to move to another application, which is in India. This is careful for me because you know India much more than I do. But Guillaume Chaumet and Urs Schultes from CIMMYT, a colleague of Francelino, has been working on tillage, non-tillage detection. This was something that we did in Belgium. We thought that only few farmers with no tillage practices in Belgium. Then we mapped that, and we were very surprised to see how many farmers were doing zero tillage. Because these are statistics that they don't exist. Nobody knows how many. In India, it's also the same concern. The residue management is actually managed by burning, and this is an environmental problem. And therefore, conservation agriculture is a way to improve the management of residue, and the no-tillage approach could be a good solution. Therefore, you have the zero-till here, conventional tillage with no residue, and all these variants. This is the area which we study. This is the signal over the season from the till and no-till. Zero-till, yes, in blue. No-till, conventional tillage in red. Sorry. The idea was to look at some ground data and there were plenty collected on the ground by the CIMIT colleagues who are based there. And you see here the zero tillage is in yellow, and in red this is the conventional tillage. If you don't have the parcel, you have to use segmentation, and you know all these tools to develop your own segmentation. And I have to say that we didn't mention that during the training, but today artificial intelligence, and more specifically deep learning, is doing a great job to delineate the parcels. You have seen maybe some application on that. This is very nice. Therefore, deep learning to delineate the parcels in landscape like this is quite nice. It's not very nice yet for Africa, but for the regular shape and mechanized agriculture is very nice. Then they look at VV signal, and the VV signal is low for the no tillage, for the no tillage, and the VH signal is the opposite. And therefore, when you do the ratio between the VV and VH, you see that the conventional tillage gives you a ratio of VVs on VH giving a high value, while the zero tillage gives you a low value. And if you look at the population, not only at the average, but the population of your different ground through, you have that kind of discrimination. Therefore, this is quite feasible to discriminate between tillage and no tillage in this case. And therefore, the question that we have yesterday, this is moving, was, okay, I cannot do area estimate from pixel counting approach because my error in my confusion matrix are not randomly distributed, and also because of mixing pixel, the mixed pixel at the edge. A way to remove the bias, I wanted to explain you this today. The way to remove the bias is to use this correction factor, where you combine actually the value from your confusion matrix, and this will give you a correction thanks to the fact that you take into account the omission and the contamination, the commission error. And therefore, you have your pixel counting area estimate that you correct by the coefficient correction factor, which is just the well-classified zero tillage plus the zero tillage classified as conventional tillage. This is your omission. And then the well-classified zero tillage plus the reference conventional tillage classified as zero tillage. This is your commission error. And therefore, you have a correction factor which allows you to remove the bias. It's not yet a rigorous area estimate, but this is an unbiased estimate. Therefore, at the end, for the different area, you can compute the area which is corrected and the proportion, of course, and you have the different overall accuracy for different number of sampling, which vary according to the place. I'm not saying that this should be implemented on a regular basis in India, but this was an example which seems to be rather reasonable in terms of result. Tillage, no tillage in our region are probably easier than in India because the residue management is more standardized. Is there anybody doing tillage, no tillage? No? You do? No. This is something very interesting for the soil. You know that in our area, the failure of agronomists is to have underestimate the soil biology. And no tillage is really a good way of managing the biodiversity of the soil, which changed completely the fertility and the resilience with regard to water stress and so on. My last example is about Mali. Having, in this case, the product from Sentinel2Agri, and this was done again in close collaboration with Solo and his team. Marie-Julie Lambert has been working in Mali for the Gates Foundation on digital globe, and we have a time series of 15 images of digital globe. Very luxurious situation, but the fields are very small, very heterogeneous, sometimes mixed crop. What was nice is with this very high resolution, and this is GeoEye in this case, this is 2 meter resolution or 1 meter resolution, you could see that the different level of fertilization was quite detectable. This was experimental plot in farmer field, and even in farmer field condition, you can see the different level of nitrogen fertilization, which was already a good sign. And in spite of the fact that there are many trees, the signal seems very, very clear. The other good news was the fact that the 2 meter is very nice, but the 10 meter do the job. 2 meter is very nice for the delineation of the parcels, but the 10 meter allow you to mask out all the trees, not the very small one, but all the trees, you can remove them, and then you can work. When you are with 100 meter, you are dead. You are monitoring the crop growth, the tree growth, the tree cover, and not the crop. Therefore, first thing was to do a crop type map, typically Sen2Agri stuff, and then you have that kind of crop type map, some very good and some not good, because the sorghum is very close to millet, and therefore we should have the dry cereal together, the millet and sorghum together. And then what you want to do is to have the crop area, and you correct, this is the unbiased compared to the pixel counting, and you see that the values are close but not exactly the same. For the different villages, now we are talking about village. When I mentioned the early warning system, global scale, you are talking about countries, and you mix everything into the landscape. Here now, with Sentinel-2, you can do village estimation. And this is the area for the different villages. And then we use a model for the crop yield, which relates actually the peak of LAI with the yield. The model is good in some crop, less good in others. These are the performances. But based on the model and the unbiased area estimate, you can have the uncertainty of your yield estimate and of your production estimate. And therefore, here, this is a standard deviation and the uncertainty of the production estimate at the village level. This is something which does not exist today. Statisticians, when they do the survey, they will say, okay, I can aggregate that to the region level or to the national level. This is less accurate for sure, but you have an information at village level. It changed completely, and with that you can support NGO, you can support development planning, and so on. This is the total production for the different crop, for the different villages. But this is not enough. What you want to tell is not that. What you want to tell is, in Mali, where can I improve the yield? Where can I improve the production? And therefore, we use what we call the yield gap. You know, this is a concept which is famous. The yield gap is the difference between the potential yield you could get in this area and the yield you are currently achieving. And the yield gap is in between these two. But the yield gap like this is very frustrating in a country like Mali because the potential is never reached by anybody. And therefore, we propose not to use that, but we propose to use locally attainable yield gap, meaning that the locally attainable yield is the best performance by the best farmer in this area, and we compare the other farmers. And we look at the locally attainable yield gap, meaning some farmers are doing that way in the village, and some others are doing that way. And we could hope that all the farmers could perform as the best. And therefore, to do so, you look at the distribution of your pixels for the different parcels for a given crop. And therefore, you take the quantile 10. These are the 10% top of the farmer. And you do that according to the crop type. According to the soil type. Using an image from dry season, we could split the landscape in 3 soil types. Not really a soil map, but big classes. And therefore, you have different soil types. And with these 3 soil types, you don't want to compare those who are in the bottom of the valley with very deep soil, with very good water, with the one on the plateau. This is not fair. You want to compare those from the plateau with the other from the plateau. And therefore, you compute the distribution for each stratum corresponding to a given condition in terms of soil, and you take the quantile, and then you map the distance between the quantile, the 10% quantile. And therefore, this is the ranking here. You are those who have a high locally attainable yield gap. Those have a big margin of progress. And the others, in green, are already very close to the best possible yield currently achieved in the region. All this is very detailed, but this is due to the fact that we have 10-meter resolution, and because we know where are the crop. And then you can do many things. And this is just an example which changed completely the way we can look at agriculture in smallholder farming system. Then to conclude, oh sorry, there's one more. It's not to conclude. Sen4Stat is about this, typically, is how can we use the wealth of Sentinel-1, Sentinel-2, here in Mali it was only Sentinel-2, to say something about production. Not to do a map, not to do a detection of an event, but to estimate the production. And therefore, there is this project Sen4Stat, where we want to work with many people, and FAO is here in particularly because they are involved in this. There are a few challenges, and maybe you have solved this challenge, we would like to know. We need now to map the perennial crop, all the permanent crop, which are not very well taken into account in Sen2Agri. They can be managed, but not optimized. But this should be optimized for the permanent crop, the tree, the orchids, and so on. We would like to develop a good yield indicator, estimate 1 month before harvest. And then we have to ingest this into what the national offices are doing. They use master framework for sampling. And actually, we have to embed it, the EO observation into their master framework to make sure that they will use it on the long term. Therefore, we hope that this will complement what is already available. And I'm sure if some of you are working on that kind of topic, we will be very pleased to collaborate. Now, to conclude, I hope that you understood that change has life completely. I mean, EO has changed the life completely in agriculture monitoring. Cloud computing is good for operational, but this is also good, as you know, for research, because it simplifies a lot your work. There is still an unexplored outstanding potential for the synergy between Sentinel-1 and Sentinel-2. Today, most of the people are using Sentinel-1 as they do Sentinel-2. You heard Ramon, there is much more to be done with Sentinel-1 for agriculture. We are really at the beginning. We hope that with this Sentinel era, we should be able to achieve the long-awaited operational application. You know that for 40 years, people from remote sensing claim that we can do full-scale annual cropland mapping. I hope now this is really feasible. Crop-specific crop monitoring, it should become really feasible everywhere. Agriculture practice monitoring and supporting the farmer, we are getting close. I hope you contribute to that. Yield and production estimate is probably the step further, which is still a bit challenging. And all these products should be made available with a good accuracy and a good precision for most countries. And this is the last challenge. It's easy to do it in US. Landsat is good enough for many years, since many years already. It was a bit more challenging in Europe, but we know that in Asia, in sub-Saharan Africa, it can be very challenging. There is many other challenges like water management that you will hear tomorrow about. But those are really the one we promised for 40 years, and I hope that your generation will solve this once for all. And this is why we propose to team up. We hope that working on Sen2Agri, Sen4Cap, Sen4Stat system is not to do the job instead of the others. It's really to remove the burden of bulk processing of time series, compilation of crop type map. These are basic products. What we want is to work from that to the relevant information for the farmer and for the decision maker. And there is a lot to be done. I'm sure you are already doing that in various ways. But it will be good if we can team up and build a user and developer community using open source system that we can plug in all together to make it available to all. Thank you for your attention. Is there any question before you go for lunch? Brent.
Just wondering if there will be also an increase in the computing requirements and these requirements for Sen4Stat, since you're merging the capabilities of Sen2Agri and Sen4Cap. Will there be an increase in the requirements of the hard disk, computing power?
Yeah, you are right that I was not maybe clear enough. I was not clear enough that our intention is to merge. I mean, Sen2Agri is running. Sen4Cap will be delivered to the paying agency. It's already delivered to some paying agency. To all paying agency, it will be done during the fall, and to everybody probably next year. I mean, I don't know when. It depends to ESA decision and EU decision. But actually, our intention is in Sen4Stat to merge all what we have developed in Sen4Cap with Sen2Agri and to make it available to everybody, not dedicated for common agriculture policy, but dedicated for generic application. And this should be available probably middle of next year, because this is already coded. We need to repackage this. And of course, as you said, the requirement will increase because you will have more data. But we hope that the access to the cloud will be also much simplified. We hope that the DIAs will do a better job than today. Amazon will do a better job. And there are many clouds around where you can run your stuff. What we understood from our experience is probably the most efficient to run on the cloud and to download your product and then to run your advanced product locally. This is our experience. Because if you have to download, they are the only one in India. And you mentioned yesterday that they download all India coverage, or at least the rice producing area, in real time, Sentinel 1, and then pre-process along the line and with Snap. But you told me also that there are 50 people. But India is a subcontinent, you know. But most of the people are doing that on the cloud because you don't have to download. And this is what would be about the practical this afternoon, is how to install the Sen2Agri either on the cloud or locally. And our experience in Mali is probably it's good to have it locally and to have it on the cloud, to have both. Because when you have a minister who visits you, you want to show not on the cloud, you want to show that it's running there. But when you have to do it for good in real time, you better put it on the cloud. Any burning question? I'm sure you can go for lunch, and we meet again at 2.